What if you could give your homemade aircraft, RC plane or drone, the same blazing navigation lights used on real airplanes using the 555 timer? Hey guys, in this video, you'll learn how to make aircraft navigation lights using the 555 timer IC. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 10 jumper wires, 2 1 million ohm resistors, a 1 million ohm resistor, one 470,000 ohm resistor, one 470 ohm resistor, a 1 microfarad capacitor, one 10 microfarad capacitor, one 100 nanofarad ceramic capacitor, 2 white LEDs, 2 555 timer ICs, a 1N4148 fast switching diode, a 9-volt battery buckle connector, a 9-volt battery, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 1 microfarad capacitor in pin 2 or trigger in the negative rail. The anode is in pin 2. Bend the ends of a 1 million ohm resistor. Insert the 1 million ohm resistor into pin 3 or output in a few rows above the 555 timer. Bend the ends of a 2 million ohm resistor. Insert the 2 million ohm resistor into the same row as the resistor in pin 6 or threshold. Bend the ends of a 470,000 ohm resistor. Insert the 470,000 ohm resistor into pin 3 or output, and a few rows above the 555 timer. Bend the ends of a 1N4148 fast switching diode. Insert the diode in the same row as the resistor in pin 6 or threshold. The cathode is in pin 6. Insert a 555 timer a few rows below the previous 555. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Insert a jumper wire into pin 3 of the first 555 and pin 4 of the second 555. Insert a 100 nanofarad capacitor in pin 2 or trigger in the negative rail. Bend the ends of a 1 million ohm resistor. Insert the 1 million ohm resistor into pin 3 or output and pin 6 or threshold. Bend the ends of a 470 ohm resistor. Insert the 470 ohm resistor into pin 3 or output and a few rows below the second 555. Insert a jumper wire into the same row as the resistor and a few rows below it. Insert a white LED in the same row as the resistor and the negative rail. The cathode is in the negative rail. Insert a white LED in the same row as the jumper wire and the negative rail. The cathode is in the negative rail. Insert a 10 microfarad capacitor into the right side of the breadboard and the positive rail. The anode is in the positive rail. Insert a jumper wire into the negative rail in the same row as the capacitor. Connect the 9-volt battery buckle connector to the 9-volt battery. It's time to connect the power supply. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. We have successfully completed the circuit. The white LEDs blink twice, then pause for 2 seconds before the next set of flashes. Let's dive into the circuit and break it down step by step. This circuit uses two 555 timer ICs to create a realistic aircraft strobe light effect where 2 white LEDs flash twice rapidly and then pause for 2 seconds before repeating. The left 555 timer is configured as an astable multi-vibrator, producing a slow timing cycle. Its resistors and 1 microfarad capacitor determine how long the LEDs stay off between the double flashes. The 1N4148 fast-switching diode alters the charge and discharge path of the timing capacitor, allowing the on and off durations to be different. As this first 555 runs, its output toggles high and low, and this output is fed into the reset pin of the second 555 timer. When the first 555 output is low, the second 555 is held in reset and cannot operate. When the first 555 output goes high, it enables the second timer only during short windows. These become the flash bursts. The second 555 timer is also operating as an astable oscillator, but at a much higher frequency, controlled by the 1 million ohm resistor and 100 nanofarad capacitor. When enabled by the first timer, it quickly pulses its output twice. The output at pin 3 drives the white LEDs through a 470 ohm resistor, which limits current. Altogether, the first timer sets up a long pause, and the second timer produces 2 fast flashes during each active period, creating the familiar double flash aircraft navigation light pattern. I hope this video has shown you how to make an aircraft navigation beacon with 555 timer ICs. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Don't miss it. Click the link in the description to get yours. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.